Let's now proceed with the next kind of questions, which is question number 11. Now here we have to find the value of each of the questions which are there. So the first question which comes is tan inverse 2 cos 2 sine inverse half. Now in order to prove this or solve this, what we do is, as we all know that when there are too many brackets involved, we start with the innermost function. So first of all, let's start with this part. So what do we get? This is equal to tan inverse 2 cos 2. Now this is sine inverse half is what? For what value of sine do we get half? For 30 degree, which is pi by 6. So you get pi by 6. This gets cancelled. So this becomes equal to tan inverse 2 cos pi by 3. This becomes equal to tan inverse 2 into cos pi by 3 is half. This gets cancelled. This is tan inverse 1, which is equal to pi by 4. Same way, question number 12. Cot of tan inverse A plus cot inverse A. Now this is yet another kind of question where we'll be using the properties. We know that the sum of tan inverse and cot inverse of the same value is always equal to pi by 2. So you directly get it as cot of pi by 2, and which is equal to, what is the value of cot of pi by 2? Cos pi by 2 upon sin pi by 2, which is 0 by 1, which is 0. Now question number 13. Another very important question, and it has been asked many times in the boards. Sine inverse 2x over 1 plus x square plus cos inverse 1 minus y square over 1 plus y square. This gives us tan of half of. Now if you just go through the last set of properties of inverse trigonometric functions, sine inverse the 2x over 1 plus x square can be written as 2 tan inverse x. Similarly, cos inverse 1 minus y square over 1 plus y square can be written as 2 tan inverse y. Taking 2 common, we get half of 2 of tan inverse x plus tan inverse y, and here this 2 gets cancelled with this, and this becomes tan of. Now if you observe in this question, we are given that xy is less than 0, and so the first property can be applied on this, and this will be tan inverse x plus y over 1 minus xy, and this gives us x plus y over 1 minus xy, which is the answer. Now let's see question number 14, which is another very important question. Now we are given that sine of sine inverse 1 upon 5 plus cos inverse x is equal to 1. This is given to us. We have to find the value of x. So if you take this sine to the other side, you get it as this is equal to sine inverse 1. Or else what we can do is we can write this 1 as sine of pi by 2 and then compare the arguments. Either ways we get this value is equal to pi by 2. So what do we get? Sine inverse 1 by 5 plus cos inverse x is equal to sine inverse 1, which is pi by 2. That is, we get sine inverse 1 by 5 cos inverse x is pi by 2. Now if you observe carefully, this is in the same form as one of the properties, that is sine inverse some value plus cos inverse the same value gives us pi by 2. So we conclude that x is equal to pi by 2, x is equal to 1 by 5, which is the answer. Now similarly you can try the 15th question also. Now let me take the next category of questions, which starts from question number 16 onwards. Now question number 16 says sine inverse sine of 2 pi by 3. The first thing which comes to our mind is that directly sine inverse is acting on sine, so directly the answer would be equal to 2 pi by 3. But this does not belong to the principal range, because here comes the role of principal range. So and what is the principal range of sine inverse? It is minus pi by 2 to plus pi by 2. That is the first and the fourth quadrant. And so you cannot do it like this. So it means that we have to simplify this or convert this into a form so that this angle now belongs to the principal range. So what do we do in this case? Sine inverse. Now we know that sine 2 pi by 3 can be written as pi minus pi by 3. Now which is equal to sine inverse sine pi by 3, which is equal to pi by 3 and which clearly belongs to the principal range. And so the answer is of sine inverse sine 2 pi by 3 is pi by 3. Now on the same lines we do question number 17. That is tan inverse tan of 3 pi by 4. Obviously first instinct is that we will write it as 3 pi by 4, but this does not belong to the principal range of tan inverse, which is first and fourth quadrant. And so again in the same manner we need to simplify it. So this becomes equal to tan inverse tan of pi minus pi by 4. Now we can write this as tan pi minus pi by 4. Now what does this become? Tan inverse of, but tan is negative in the second quadrant. So this becomes minus tan pi by 4. Now to be able to make tan inverse act on tan, we need to absorb this negative sign. So now how do we absorb it? It becomes equal to tan inverse tan of minus pi by 4, which clearly is equal to minus pi by 4, which belongs to the principal range, that is minus pi by 2 to plus pi by 2. So this is the answer. So we won't report the answer as 3 pi by 4. We will report the answer as minus pi by 4. Same way you can try question number 1 and question number 2 of the miscellaneous exercise, which are on the same lines, and you have to proceed in a similar manner. Now same way you can also try question number 19 of this exercise. Now let's quickly take another kind of question, which is question number 18. Tan of sine inverse 3 by 5 plus cot inverse 3 by 2. Now we haven't done any result which gives us the value of sine inverse 3 by 5 directly or cot inverse 3 by 2 directly. So also we don't know any property involving sine inverse plus cot inverse. So what we do is, in all of the questions of this kind, we convert everything to tan inverse, because we have done the result for tan inverse x plus tan inverse y, and we know how to use them. So now what we do is, we put individually, we will solve. So first of all, we will convert this sine inverse 3 by 5 into tan. So let sine inverse 3 by 5 equal to, let's say, t. This gives us sine t equal to 3 by 5. We will directly use the Pythagoras theorem to find this. This angle is t. This sine means perpendicular upon hypotenuse. So the third side is 4. Now this can be written as, from here, tan t can be written as 3 by 4, perpendicular upon base, which gives us t is equal to tan inverse 3 by 4. So we started with t equal to sine inverse 3 by 5, and we have arrived at t is equal to tan inverse 3 by 4. So we can clearly replace sine inverse 3 by 5 by tan inverse 3 by 4. So this becomes tan of tan inverse 3 by 4. Similarly, the other one can be done, but here it is already cot inverse, and we know that cot inverse x is equal to tan inverse 1 upon x. So this gives us cot gets converted to tan inverse 1 upon 3 by 2, which is 2 by 3. So we have got tan of tan inverse 3 by 4 plus tan inverse 2 by 3. Again, 3 by 4 into 2 by 3 is less than 1, and so we can use the formula directly. It becomes tan inverse 3 by 4 plus 2 by 3 upon 1 minus 3 by 4 into 2 by 3, and this gives us tan of tan inverse. Now let's see, what do we get? Here this becomes 9 plus 8 upon 4 into 3 upon 12 minus 6 upon 4 into 3. This gets cancelled. More so, tan when acts on tan inverse balances it out, and we are left with only this number, which is 9 plus 8 upon 12 minus 6, which is 17 upon 6, which is the answer. So in this manner we solve the questions which are of this kind, and you can try out the remaining 3 questions, and then in case of any doubt you can post in your comment section. Thank you.